Hi everyone. So this is Deepti Agarwal, and today we'll be continuing our discussion around core algorithms, and more specifically some patterns that we can identify to solve problems in different categories, right? And we started with this idea, sort of mini series 2 weeks ago, where we started with the topic of, um, we started with this topic of arrays and the idea, I don't know how many of you here had a chance to attend this session 2 weeks ago, but just the high level idea is that there are different ways to prepare for interviews. What we are trying to do with this mini series is more like to approach it in a breadth first manner rather than depth first. So on lead code, for example, you have about 1,500 questions. So if you pick one topic and you start practicing questions, right, which is great if you have time. But what if you want to, really pack stuff in a certain amount of, limited time? Then how do you approach this preparation so that you have covered problems in different categories? So you have a sense of different types of algorithms. Given more time, you can of course practice, but you should have at least this minimum, set of problems under your belt. So that's the idea we started with. And today, initially, I thought we can finish all the linear data structures. Like last time we talked about arrays. So I was planning to cover linked list, stacks, and queues today. And that would have covered the linear data structures, but just linked list itself became quite interesting. And I thought the questions I have would itself take some time. So we are going to stick to linked list today. And I'm just going to, this is from last time. So I'm just going to skip this and yeah. So talking about patterns, right? This is how I approached it. On linked list, if I just do a simple search by linked list on lead code, I see about 40 to 50 problems there. And I didn't had a chance to, attempt even 90% of them. So the way I approached was I sorted the problems based on the frequency at which they are asked in different companies. And also I paid attention to the acceptance rate, right? So these are just the 5 problems here, but today we'll also see, I also covered 3 or 4 problems which talk about these two techniques. So in overall, you can say that I practiced about 10 problems on linked list, and these are the two main patterns I see there. One is the typical algorithms on linked list which involve reversal, which can be done iterative and recursively. And there is also a variation of this problem we'll see. So that is one category of problems that I observe. And the second is called the runner technique. So back in arrays, if you remember, we talked about this idea of two pointers approach, right? Where we said that we have a sorted array and you can have 2 pointers walking in opposite direction. And you can try to find the target sum and problems like that. So this technique, runner technique, and more specific, I mean, it comes in 2 flavors. You can think of it as, again, 2 pointers based, but it's a little, there's a small variation of it. One approach is called that you have 2 pointers and one is starting at a certain, ahead of the, like if you have fast and slow pointers, then fast pointer is starting X steps ahead of the slow pointers, right? And then they are doing step by step. We'll go over the problems, specific problems, but I'm just trying to give you a flavor of what the type of problems are. And the second approach here, as I have said, fast and slow pointers. I mean, I believe everyone here in this group is kind of in some degree, you are practicing algorithms. So this comes as a canonical example of where the pointers are moving at different speeds and you try to use them in problem involving cycles. But not to jump ahead, the crux that I want to convey here through this slide is that in linked list, they are primarily, these techniques being used to solve problems. And before moving on, I also wanted to highlight actually this one. So I happened to watch this video. Uh, so we have this Cracking the Coding interview book club session. I think Santosh and Shashank and this was the session where they covered some problems on linked list. So I encourage you to go and check that out as well. They have talked about how to approach different ideas and, then showing the code for the specific, approach that they took. So this is another, reference you might want to keep in mind. Yeah. So this was my idea of picking these problems. And now let's get on to the specific things here. So like I said, first pattern I'm thinking is if I were to solve in a lot of problems in linked list, we observe that it's all about, when you have to, for example, reverse, how do you play with the, these adjusting these pointers, right? And given that we are dealing with linked list, that comes as a basic that you would be playing with these pointers. But what are some coding patterns that you can keep in mind that are usually helpful? I'm not using the term that they're always, because there might be problems that are done differently, but they're usually helpful to solve these kind of problems. So let's start with this basic one. Can somebody, just go through the process of how we would, think around approaches to this problem? So basically, like just a simple one, right? You're given this input list and you have to reverse it. So you can talk about any recursion, iteration, whichever way.
Yeah, iteration. Yeah, you could use two pointers, right? In this case.
Okay.
So,
Okay. How can you elaborate, Santosh?
so if we can, if we are pointing to the start of the list, right?
Right.
And then, when you start, so then you can actually store the next, because you will have to initiate some pointer which is the previous one to
Okay.
something like a null, and then
Okay.
you start with a while loop, wherein you actually initialize that while loop with your head. Okay,
Okay.
so then you store your heads next, okay,
Mm-hmm.
in that while loop, because you will be needing that. And then your current head, actually you point to the previous. Okay, so this is the way you are actually reversing the first element. Okay, but now your current is pointing to the previous, and you next you have already stored.
Right.
So then you'll have to jump your current to the next. Okay,
Mm-hmm.
and when you are jumping your current to the next, then then when you come to the while loop again.
Right.
Okay, and then you'll have to move your previous pointer also in that case, right? Because
Mm-hmm.
your previous pointer will be your current in that case. Yeah,
Sure.
before you when you actually move your current. Yeah,
Mm-hmm.
so
Yeah.
if you do that, yeah, so
Yeah.
something like that, yeah. So
Right, right. No, I mean, you're spot on with that. So
right, right.
I can show the exact one, but how about like we also, so now you have talked about, you have hinted at the specific, how you would implement this algorithm. You have
Mhm,
talked about you're going to use this previous and next node, you have to store and all of that.
mhm.
How about, can you also maybe, um, or over, like basically, did everyone get idea that Santosh was presenting, or any questions on this? Okay, so I'm going to take silence as it's all good, but if you have questions, please jump in. So
Yeah,
basically we are trying to, just iterative, Santosh talked about this iterative solution where we are saying that we are going to take care of single node at a time and shifts its pointer, right? So you're having, for example, he talked about this previous node. So you're going to set this in the first one, and your rest of the loop will stay the same. This is how your first thing will become. So you have changed this link between 1 and 2. You have moved this to, previous. So your null, so you start with the previous pointer, which contains null, and you shift the pointer of first node. But you see why he was talking about storing next node, because once you change the pointer, you lose the access to the, list. So you need to store two, so that you can access it. And in each iteration, basically you are handling one node at a time. So in the second iteration, this is your first iteration. Then in the second one, you're going to do this. And so the main idea, the way I took this question after I solved it was, um, how it is important to, having these three kind of pointers: previous, next node, so that we don't lose control of the list, access to the list, and your current node that you're dealing. And you will see in the solution that I bring up, uh, this is the main gist, right? How I'm kind of resetting them and how I'm playing with them. Um, and it just simplifies your code. Like, when I think this problem at, in general, have become a very standard problem that all of us would be very comfortable with. But you'll see this pattern coming over and over again with linked list problems. And if you keep these three pointers variable approach in mind, it becomes very easy to write the code. So yeah, so this was the iterative solution. How about the recursive one?
So one doubt, like sometimes we are using dummy nodes, sometimes we are not using. Like if you go for the uh, what you say reverse pairwise, there sometimes you use dummy node. Here we are not using dummy nodes. Like, is there any hard and fast rule, or it's like,
So which question you're talking about?
I mean, there is slight between,
Pairwise, okay, like one and two, and then three and four, like that.
you
No, he's saying instead of using the lease itself, uh, because we have other problems where we use dummy node, and the
Okay,
dummy node points to the head, you know,
okay.
so we don't lose the pointer, so therefore,
Oh,
yeah,
actually, there is a problem where, yeah, I have even used that pattern. Yeah, so there
yeah,
are, patterns like that where, um, yeah, you might. Yeah, I'm trying to think if I can craft some, on the top of my head, if I can think of some pattern, but that might require some thought. But
right.
I think, to your point about using that dummy node, I have seen problems which do that. But from your question, I am kind of, it makes me think, what, how would I identify, sort of, or is there a pattern to it?
Yeah,
Uh,
but I think, in the reversing a linked list, Shashank,
yeah.
do we really need a dummy node?
No, but if you look, one question is on lead code merge pairwise. I mean, sorry, reverse pairwise. There we use dummy. Like,
Okay, okay.
yeah, so, here we are not using it. So at times we use, at times we don't use. So is there any like something when to
Yeah, but
use?
actually for the reversing, this is the best way to do, right? That
Yeah,
is what I would say. But the pairwise is slightly it's not so easy problem.
yeah. There we are using this.
Yeah. So in that case, you might, uh, but yeah, I usually avoid using a dummy node because then you have an additional management to do on that front, right? So, but yeah, it is helpful in some cases. Maybe the
For
pairwise
more
is the best
problems, it's
example, but
fine.
for the reverse, I think this should be okay. Yeah, maybe yeah,
So my
you can.
question is, if we are just quickly talking, we won't spend too much time. But I'm just curious, if we are talking about reverse, then we are saying we have to do something like, first two nodes reversed, right? Two to one, and this is four to three, and so on. So what is the intuition behind using, like, how would I identify to go something that route?
It becomes easy, and Namrata is mentioning, but like, how come we know when to use in the
Yeah,
chat?
right. Exactly. So
So
yeah,
basically, in which scenario that pattern can be applicable, right? Yes, it
right,
is easy in this problem, but how other similar problems we can solve, right? So that's the
right.
pattern.
Exactly. That's what in general, the goal is that how do we identify those scenarios? In past, in arrays, like for example, when we say sliding windows or something, we kind of have some identification, right? If you're asked about subarray and all that. But yeah, I have
So
taken note of this. So this is
yeah,
interesting.
just one quick note. I think element of programming introduced that book talk about use dummy node for reversing also.
Okay.
And basically, the idea is that whenever, suppose you are doing something like, let's say, merge or reverse
Yeah,
or
yeah.
something, where, otherwise you have to put a lot of if and else condition. So there you can start with the dummy node. So you don't have to like, oh, first list is null or second list is null, or suppose you are merging two sort of list, whether the first
Yeah.
one is on the list one or two. Or in that book, basically, it use reversing also using dummy node. And uh, so I think a lot of problem, most of the time we can use dummy node, and it will make it easy. Basically, you start with the dummy node, but while returning, you just return dummy dot next.
Right,
At the
right, right. That's the pattern I have used in that merge problem.
Yeah,
But yeah, I couldn't see, for example, I think was somebody saying that we could use dummy node even in this problem.
yeah,
And
I think so.
so,
That
but
is what
I
Bhavesh
can't,
said.
I can't be sure about the intuition.
Okay,
Like why.
okay.
Yeah. So, but yeah, interesting. I only saw one problem using that dummy node, and I interpreted it very differently. I'll talk about why I thought dummy node is useful, but it's interesting. Like Bhavesh, you were talking about this elements of programming interviews, right? So we'll
See, in this case also you can use the dummy node, because at the end of the reverse, right, your x is going to be the head. So if you create a dummy node, you just point to dummy dot next is equal to x, and then you return dummy, right?
so my dummy node will be pointing to after reversal. Like where will it point to?
So it will point to last node, right, which is 5.
Okay.
And then so dummy, basically dummy will point to 5. Dummy dot next will be 5,
Oh, dummy dot next will be fine. Okay.
and then you return dummy, right?
Okay.
So in
So
that
you,
case, yeah, I mean, you can, I think that's kind of it can be applied here as well, because whenever we reverse, right, so here, so the tail node is, so basically after we reverse, the 5 is going to be the head. So
Right.
one thing is that you return 5, okay, whatever your because we
Yeah.
cannot return null node. But let's say if we create a dummy node, then we have to link between dummy and the head,
5. Yeah. Yeah.
right?
And then,
Then you return dummy, right? As long as they are all linking, it
yeah.
really matter. Either you can start from 5 or you can start from 2 other dummy, as long as they connected.
Yeah.
yeah. So I think the previous node actually can be the dummy node, right? So because in this case we will be returning the previous. So and always actually previous dot next will be null in this case.
Mhm.
So we then keep on moving it, and at the end your previous will be pointing to 5, right? So that might be a way. Yeah, yeah,
Yeah, in this
makes
case,
sense.
we are returning the previous one, which will
Right.
be 5 at the end.
Mhm.
So is that like using dummy node is always better? I mean, is
No,
it
I mean, we can
want to
talk.
use dummy node?
No, I don't think it's about better. The way I see this is it's some problems. For example, one I can take specific example, like one problem I can address like directly merge list problem, which we'll be talking about. I don't see how it can be solved without a dummy, pointer. So that was my intuition that I I don't see that problem can be even solved without dummy node. So I don't see dummy use of dummy node as an efficiency metric, but more as a functionality, like for my algorithm, core algorithm.
Yeah. So like in your iterative approach, we still can use dummy node, right? We
Yeah,
just
that's what I'm
not
hearing. We
want to
can,
use it, but we
yeah,
Yeah, I think. I think in general, it just makes your code little bit less, or little bit cleaner. But other than that, I think we can do without dummy node as well. This one, definitely.
one
yeah, this
case
one.
I one case I see using dummy node. dummy node is helpful. It's like, in case we have somehow we have the circular linked list, then, use dummy node. We started, the next, point to the, well, let's say we create a dummy node and the next also point to the dummy node. Right? That one would be helpful.
Yeah.
So yeah, like in case of, if we do in this case, if we do reverse in recursion, I would think using dummy node in that way would help.
I mean, yeah, these are good ideas, right? Because I haven't tried these problems specifically, like this one reversal using dummy node. So this is something maybe we can take as an action item and try to, I think we all have some idea about how to use it here, but if we want to go and try it out, that's something we can do in the session. But just in the interest of time, I think I'll continue here. But yeah, great discussion. So recursion, somebody wants to go over the quick idea about how we'll solve this problem recursively.
Okay, I can go.
Sure.
So let's say, let's say I'm at node 1, I'm process node 1.
Yeah.
I am currently node 1. I would recursively call, reverse point to the next, which is called reverse on node 2, right? And one it's done, then I just need to append node 1 to the tail of the result, and then return the result.
Great. So
the process is to like, let the recursion do whatever it needs. Like I'm at the current node, right? And I say, okay, go ahead and do reverse on the next node, right? When it's done on the next node, then it return a linked list, and I say, okay, now append 1 to the end of that linked list, append the current node to the end of that linked list, and return the result.
Yep. Perfect. So yeah, so like I'm putting down what Leon was articulating, right? So you handle one node at a time again, but rather than having all these extra variables and doing it in a loop, you think in terms of, in recursion, usually the idea is you try to find a base case that you can solve easily, and then you pass the rest of the problem, you solve rest of the problem recursively, right? So here my base case is that I know how to reverse, for example, a 2-element list, right? I can do this as 2,1. This is kind of my base case. And from here, I try to formulate my algorithm. So I say that I can reverse 1 and 2 by changing the pointer, right? And then my recursion will take care of reversing rest of the list in the same way. So I say that this is my first step, right? And then I say in the next iteration, I am saying I can reverse the next pair, which is 2, 3, and recursion is going to take care of the next, right? So that's the idea of recursion. Now, when will you use one over the other? Like, where do you think, think about this, if you get this problem in an interview and the interviewer doesn't say recursive or iterative, how would you, start about it, or how would you approach this problem? And what were your thoughts about?
I would prefer to use, for this problem, I would prefer to use the iterative way.
Iterative way?
Yeah.
Why that's the case?
Because it's recursive is always slightly difficult to come up with, right? Yeah, it's easy once you get the hang of it, right? As you said, you keep on reversing and pointing to the
Right. So one point in
tail,
general recursion is like, it comes with practice, right? You can think recursively, but to actually code it, it needs a little bit of more practice. So one is like code simplicity, right? Sort of, not simplicity, I would say proficiency, what you're comfortable with. Any other reasons that you see here where you would prefer one over the other?
Yeah, because if
I
the
think,
linked list is huge. Oh, sorry, go ahead. Vash.
yeah, same thing. We have to think about that, stack size as well.
Right, right, exactly.
That
So,
is the main thing on this in a list, because list can go easily very long.
right. So this is, like the performance aspect, right? Or the space usage. The iterative is kind of in place, right? You're only using a bunch of extra variables, which is more like constant space. But in recursive solution, you're using stack space by default. So if your list is huge, you have to think about that. And just a problem as simple as this is kind of considered as a standard canonical problem, but you can see that um, my takeaways from here were, how do I show one's knowledge of one algorithm versus other, like the space issue that Bhavesh mentioned, and of course, like the code proficiency stuff is there. So how do I articulate this to the interviewer? This definitely is good. And the second point for me was, when I was practicing this problem, how do I explain my algorithm in simple plain English to the interviewer to start with. And then I should also have clarity about, I should have enough practice that makes me think, okay, once I explain it, oh, I have to use possibly different pointers, or, this is how I'm going to implement it. So these were my three main takeaways from this problem. I see some chat messages coming up. So if somebody can keep an eye, or whosoever is posting, if you want to speak up, I won't be able to track chats. So yeah, so this is that problem.
So
And
this linked list, right? I can think of another correlation is think about you have a tree which is not balanced, right? Which is like a million node, and so in tree also we are using recursion, but it is more efficient because it is balanced, right? But in the linked list, it's kind of a like a
first,
completely
like, yeah,
right. It's kind of unbalanced, and if you have a million node, you can easily and if you have a smaller RAM, right, you cannot
right.
really fit into it, right?
Exactly. And this is one
So
of the arguments in general we use when we get to tree related,
exactly, yes,
that
yes,
we
and
say,
that
oh,
is
if the
yes.
tree is skewed, then it becomes a link.
It's there is no point of using any recursion, right? It's exactly like the linked list recursion program. Yeah.
Right, right. Yeah. So I don't know if, I mean, I have solved the problems. I can share the links, but just as if you want to see the quick code here. So I've solved it like iterative, like I was saying, basic. Oh, this is recursive. Yeah, I mean, iterative is simple, the same idea, right? Exactly. 3 pointers and then 3 variables, and then you play with them. And to me, a problem like this, like if I don't have enough practice, or if I may have enough practice in linked list, but I may be in my mind, I might not be ready with, let's say, trees or dynamic programming. And during the interview, if that pressure is there, right, you don't know what question is coming up. A question as simple as that can make you like trip over that, oh, playing with pointers and stuff. So yeah. So, and then this is recursive, same idea. Like you see how I'm trying to do, like passing the remaining list, and then, uh, I mean, you can see the exact code, but the idea is what we just talked about. So let's move on to the variation of this, which is, you want to reverse the list from position M to N. So here we are saying, I want to reverse it from second node to fourth node. So you see the output here, right? So, um, so what about this idea? I mean, I think it's very much like you can build upon the previous problem, but I want to emphasize one point here. Maybe I can just go over it and we can move on to the next category. So here also you see you are essentially doing reversal, like 432, you'll follow the same idea, but the difference is you're not like starting with the first node and setting its pointer to null. Now you have an existing list, right? Like the list till this point, uh, node 1, that you have to attach to. And similarly, you have a list beyond 4 that you need to attach to. So it's not simple, like you can't set the previous node to null and move on. You have to be able to, once you get to your mth node, you need to have access to, or you need to have some variable which is pointing to your m-1 node, which is node 1 here, that you can attach to your reverse list later on. And similarly, you want to have a handle on your n+1th node so that you can further attach it to the reverse list. Does everybody see that idea? What I'm talking about?
Yeah, so you are trying to say that first we have to go to the mth node.
Yeah.
Yeah, and then do a reverse of that m n to n.
Right.
And you have to keep that pointer of n+1 so you can
Yeah.
actually attach it. Yeah. Mm-hmm.
You have to keep m-1 pointer and n+1 pointer somewhere.
Mm-hmm.
Yeah. So that's like a simple idea, but I think this kind of question, I can see it being appearing in the interview because it tests both your reversal and also this, a little bit of thing that you have to play with about tracking the previous and next nodes.
Yeah.
And I didn't try that pairwise reversal. That also sounds interesting. Somebody wants to look at it. Yeah.
But this is also very challenging one, right? Even if it looks simple, it's not simple
Yeah.
at all. Yeah.
Like I think I'm pretty sure I tried.
Anytime you solve it, again, you are not very sure whether you have
Right.
really
Like
done
you
it
have
right.
to be very clear about your algorithm in mind.
Right.
During the middle of the algorithm, you'll be like, wait a second, like, how do I do that?
Yeah.
So this is the challenge with this stuff. So you can see the lead code solution right here.
Yes.
Okay. So this is what I was saying. I'm keeping track of my m-1 node, and then I'm doing the regular reversal here. And I also have to keep track of, this is my sublist reversal. And then I also have to attach the n+1th node, that kind of stuff. But yeah, I mean, this is more like implementation idea. So this was one technique where you can keep in mind that for reversal, trying to think of these multivariable approach will make the code implementation easier. And we also talked about use of this dummy node, which I'll show an example in one of the problems, but we may want to explore more. I don't have examples for it in the reversal case. So let's move on to the next one, which is, oh, this was actually the same pattern, but this is a very interesting problem. Determine if the list is a palindrome. All right. So yeah, how about, so let's go over this one. Would somebody want to talk about, so let's say you're given this question in an interview, right? You have to determine if a list is palindrome or not. How would you go about it?
Well, actually,
Mid of
go.
link.
Oh, sorry. Yeah, go ahead, Shashank.
Yeah. I mean, similar like slow and fast pointer to get the mid of a linked list, reverse it and then append it right to this.
Okay, this is
And
lead code practice speaking up.
okay.
No, I'm just laughing that you have a lot of
Yeah.
practice.
Yeah, but that's a very good way of doing it, right?
Yeah,
From
that
what
is
he
like,
said. Yeah.
like, but I mean, when I looked at this problem, I was like, it didn't even occur to me, all this middle and reverse and all this stuff. But this is it, right? This is the optimal approach. And I guess Shashank was trying to give everyone a demo of the value of attending lead code practice. So you can,
Yeah, he's a brand ambassador of that. That's for
yeah.
sure.
So if
But
we reverse the input and
Mhm.
compare it one by one, would that work?
Yeah, I mean, as a naive approach, right? Like as a first solution that comes to mind, I won't call it. Like knife sounds like very, a little less. But the basic idea I had was like you were saying, Leon, right? I would just iterate through the list, maybe dump it in a stack, like 1, 2, 2, 1, and then just do another pass of the list and compare it with the top value that I'm getting from stack, right? So because in stack, I'm going to put it in reverse order. So I'm just going to match that way. Sure, we can definitely do that. The only the challenge there is extra space used, right? And you're using multiple passes of the list. So yeah, so that's definitely a solution. But can we do better? Like here you have an hint. This problem can be done in order of one space. And I think Shashank already talked about it. So what he was suggesting is that um, since we're talking about now my point is when like the solution that you came up with, Shashank, so that is a good one, but what is the intuition behind it, right? We have to catch that. So the way I thought about this was it's a palindrome thing. So I have to do this, front and end, like have to match. So how can I break it up in two parts? And uh, I can't go back, right? It's a singly linked list. So I have to find a way that I can compare the first and last node, right? By going only in the forward direction, right? That was my takeaway after reading this middle, the approach you were talking about. Uh, is everybody catching the idea here? Or if I'm going too fast, please let me know.
So yeah, that is good, but the only thing when you look at the problem, it says it's a easy bucket, right?
Oh,
So
it's an easy because you can put it in stack and you can compare it.
yeah. So that
The
is what I was
follow
saying.
up is
Like
actually medium. So,
Follow up is
yeah. So because the way Shashank said, okay,
right.
that is not easy. Correct.
Of course, yeah.
Because if
That's
you
at
yeah, go ahead, Shashank.
That's a follow on.
between at least medium. I mean,
Yeah, it's
Yeah,
medium. Because if you find the midpoint, that is one thing you have to do. That's one problem in itself, and then you reverse it, right? That's the second problem. And then when you actually do all the comparisons, and if the interviewer says that we have to restore the link
right,
it again, so that
right.
will be a third problem, right?
Yeah.
yeah, the problems in
Yeah. So
So
always better to go with the stack to start with, right?
right, right.
Yeah.
And that also, I mean, to
or
me,
you can create a new linked list, right? I mean, yeah, it's
of
exactly like
course,
the same
yeah,
space.
Yeah.
But I think there could be one scenario can happen, right? Like think about in a real world scenario, you want that linked list, right? Below down the some method or somewhere the code is being used, and now you modified in place just to make sure that yes,
no,
in the
no,
interview
yeah, but that's where we are saying that if you modify it, then you have to restore it before you end your
yeah,
right.
correct, yeah. Once you check it, right, you need to make sure it got restored. Yeah.
Yep, right. So these are the kind of things that are very, I think, useful. And, when you highlight these to the interviewer, these kind of show that we are thinking, ahead. We are not just thinking about, okay, one aspect. And to me, it kind of speaks of, and even if you start with a stack based or another linked list idea, right? It kind of shows the logical progression of thoughts rather than, finding the optimized one. And if you have done a similar problem, right, you may come up with an optimized one right away. But my approach is that I can say that I've seen a similar problem like this, and this is how I think I know of a pattern which helps to optimize it. But a basic solution would look something like this, um, just to show to the interviewer that you know uh, I know kind of how to take it piece by piece. Um, yeah, but this is a very interesting problem to start with the basic one and to actually other way to look at this is all these canonical problems in linked list. Find the middle element, reverse the linked list, right? They may not be asked as is, right? They may be a part of a bigger problem. So once we understand, once we have practiced something like this, then it becomes interesting to see how they're applied. Yeah. So does everybody see the idea here? Like if we are looking at second example, we are saying that we are going to break it in half and then reverse the second half. So this will become 1, 2, and this will also become 1, 2. And then maybe I should, if I can quickly just write it here. So we are saying we are going to have 1, 2, and then we are going to have another one called 1, 2. This is after the reversal, and you're going to have one pointer on the first one. And second pointer will be at the second, in this case. And then you just move forward and compare the values. If they match, if they match all through, then it's a palindrome, otherwise not. And at the end, you should again reverse it to make it the same as the original list. So yeah, I thought that was a neat idea. Put down the main highlights here, right? I got this from lead code itself. So you find the end of the first half, you reverse the list, and then you just compare. And at the end, they are restoring the list as well. So, yeah, so that was a good one. Now moving on to the second technique, which is runner technique. I'm going to keep a tap on the time. So we have till 10:30. Okay. 9:45 or 9.
Hey, DP, sometimes your voice is low. It actually goes low. Am I the only one hearing that?
No, it's like that. Sometimes we speak quite quick.
Maybe I am placing my laptop a bit. Is it better now?
Yeah, it's good now. Yeah.
Okay. Yeah. So second idea is this runner technique, right? Where we are using 2 pointers. And the 2 patterns here are, there would be some problems where you are positioning one pointer, certain nodes ahead of the second one, and you are just progressing them one node at a time. So it's a one-time thing that you're putting one pointer ahead of another one. And the second idea is the typical tortoise and hare problem, where you are moving one pointer faster than the other one, right? So these are the 2 main ideas. And this was, yeah. So let's go over this typical problem here, middle of the linked list, right? We all know that we are going to have these 2 pointers, fast and slow, and initialize them to the head. The fast pointer will move by 2 hops and the slow pointer will move by 1 hop. And when the fast pointer gets to the end of the list, your slow pointer will be at the middle. That's the idea, right? And the interesting point is this algorithm, this technique looks very, unique, but it is applied in a lot of similar problems where we have to get to the middle of the list or detect a cycle. Any other like this was a typical technique, right? What other approach you can, like a brute force approach, would you follow in this one? And you're given like number of nodes are between 1 and 100.
So I mentioned one in my chat.
Okay. Yeah, like I can't track the chat, so if you can speak up.
Yeah. So what I'm trying to do is I'm trying to maintain 2 pointers.
Okay.
One will be through my recursion, and the other one is a kind of a global one,
Okay.
which is the front. Like
Uh-huh.
I've shared the code in the chat also. So initially, my front pointer would be at my first node.
Yeah.
Okay, and I'll then go through the recursion normally and wait for my recursion to reach the last node.
Okay.
Okay, so basically at this point of time, I have one pointer at my front node and one at the
Right.
last node.
Right.
So I just compare these two values.
Uh-huh.
If they are same, then I move ahead. So move ahead as in I increment my front pointer and then I go
Are you
back from my
comparing
recursion.
them? Why are you comparing them?
Because then only I can ascertain that they would be a palindrome or not.
This is not a palindrome question, right? This is the middle.
Oops. Okay.
I think,
Yeah, this is slightly different. Yeah, yeah.
yeah. I
So
see what, yeah, what you
if
were explaining was like, I see your point idea in the palindrome idea, in the palindrome question, that you're getting to the last node by recursion, and then you're comparing. And then when you pop the node from the stack, from the recursion, you get to your second last node, and so on.
Mhm.
So,
Yeah.
yeah.
But
So,
Shashank discussed about that palindrome only, right? Or was it something else?
yeah, that was
That
palindrome.
was palindrome. Yeah,
Now we have moved on to, you all can see my screen, right?
Okay, okay. I'm really
yeah,
sorry.
yeah. No
No,
problem. Yeah, you
that's
joined
fine.
a little late. Yeah, that's okay. Yeah,
Okay, no worries.
yeah.
So, yeah, so this is the middle node question. Um, I mean, a very basic approach would be you count the number of nodes in the list, and then you get to the index of the middle one, and you access it, right? It's a multi-pass thing, right? That's the issue there. And usually this fast and slow pointer is the technique where you can do a single pass, algorithm. And one other thing I noticed was as a naive approach, I thought of this one, right? Like just count the nodes and get the index of the middle one. But then I noticed that in the solution, they had given, right, nodes can be 1 to 100. So this also tells me that I can just have an array, right? Um, and I mean, of course, at the expense of extra space. I can have an array because I have a reasonable size, and I can just, to access the middle element, I don't have to do the traversal again. I can just, get to the array index and get it. So some things to keep in mind, right? Like, let's say you're not given the last constraint in the interview, but it's an interesting thing to keep in mind as a follow-up question to ask to the interviewer. Uh, yeah. So I think somebody raised a hand.
Okay. I,
Yeah,
I,
I Namrata is there. Yeah.
I have a question. So,
Yeah.
DP, so with this fast and slow pointers, we're saying, okay, so fast is moving twice as fast. When fast is at the end of the list, we're saying slow is exactly at the middle, correct?
Right.
Okay.
Yeah. Yeah. Uh, any other question?
No, I think we are good.
Okay. Yeah. This is the typical thing. Uh, what do I have here? Oh, this is the typical cycle related problem. And it's very similar to the previous one, like the fast and slow. You're going to follow the same logic. The only difference is at this point, you will see that since the list has a cycle, right? It won't, fast pointer would never reach the null, right? So the idea is that, and there is actually we won't get into it right now, but if anybody is interested, we can talk offline. There is a sort of an intuitive conceptual proof to show why this logic works. That in this case, they're saying if the list has a cycle, then there will be a point where fast and slow pointers will meet, and that will show that there is a loop. If they don't meet and the fast pointer gets to the null, then yeah, there is no loop. So that's the idea. Um, and that's where it gets its name, tortoise and hare problem. Um, but yeah, this is the logic here is very similar to the previous question. The only difference is that I'm adding this condition that fast and slow, if they meet, then there is a loop, otherwise not.
Okay. So, DP, one thing in the previous question, you had initialized both your slow and fast as
To
head,
the head, yeah,
right?
right. Yeah, so
But
this,
in this one, I see your fast is head of next.
right. So this is another, I'm glad you brought this up because I had a similar question. So in some problems here, what we see is like this is a mix of where you are where you are moving your pointers at different speeds, but you're also starting them at different positions, right? And I have seen problems where even this condition, people are playing with this, like you're sometimes checking fast dot next and all of that. So this is one question I had actually in the coming slides, but we can talk about it here. Does somebody have an idea about, I just, saw this solution online, but does somebody has an idea about what is the intuition behind doing this? Like, how do I know if I have to initialize fast as head or head dot next?
I think it is because of your while clause. Here it is slow not equal to fast. So if you assign both to head, then it won't even enter your while loop. So actually people are doing the similar problem by assigning slow equal to head, fast equal to head. But in your while loop, in your while clause, you put the first condition where
Is the
fast
voice
equal to null and fast dot next equal
breaking
to
just for
null.
me, or is it like she's having internet issue?
What is it? Sorry. Is there audio problem? Or?
No, I think it's from my end only. Yeah.
Okay. Yeah, but that makes sense. That makes a lot of sense. What I don't know who was speaking, but since we are comparing this fast and slow pointer, that's the whole essence, right? Where they meet, there is a loop. So we can't start them at both at the same position. And if we do start them, then you have to tweak the logic somewhere in your while loop, right? How you're checking it. But that makes a lot of sense.
Is that the only time we're gonna use technique where we point slow to the head and fast to the head dot next? Or because
Uh, there is one other question where I see that they all both start from the head, but this condition here, right?
Mhm.
If condition, they're at one point they're using like fast dot next, they're comparing it. But I haven't, I mean, I know there is a question like that. I haven't, solved it, but I think that might be another area to think about. But at least, this makes sense, right?
Right, it does. Yep.
This intuition makes sense that why we are using one.
Yeah, I think we can use the other way also, right here also. So it only depends on how much you are comfortable with that, right? In this case, you'll have to be very, when you are saying fast is head dot next, then you are just comparing slow and fast and your
Right,
while
right.
start, right? Yeah,
It's simplicity also, like in your thought process also,
right. Yeah.
it's simple to think. Yeah.
Yeah, but it's a cleaner code, absolutely. I
Yeah,
agree.
yeah. But it's a very good question. I mean,
Yeah.
these are the things that kind of trip us over while actually in the interviews, like sometimes. Good. Um,
Do we have proof for this, like why they match? Because that is most important. They ask, right? Like why fast and slow pointer meets.
uh-huh.
I mean, why fast and slow pointer meets? We have proof for this, right?
Right.
Something.
Yeah, there is a proof for it. And just because I can take it up, maybe if we have few minutes at the end of this, because I want to do that mock interview practice that will require some time. But there is a very interesting conceptual, logic about it.
Yeah,
Um,
definitely they'll ask in interview, like after once you write the code for
yeah,
this.
actually, that can be a good thing to check, right? Whether you are really understanding the concept or you're just like, cramming the algorithm.
Kind of you.
Yeah, yeah. But yeah, definitely let's take this at least offline if we don't get time right now. So I'll post it offline or remind me, just ping me. Yeah. Okay, so let's. This was another problem which I just added at the end. When I was looking through that CTCI book, and it actually uses a similar idea of this, two pointers approach. So I thought of adding this up here. I don't have the code implementation for it, but we can definitely talk about the algorithm. So intersection of two linked list, right? So you see here an example. So we want to here point answer should be C1. And similarly in the second one, answer should be 8 and so on. So how do you think we can solve something like this? And don't get carried away by, oh, we have to use this technique. In general, like think about, you get a question in an interview.
Okay. So in this case, what we can do is, we can, anyway, we will have 2 pointers starting at A1 and B1, right?
Uh-huh.
So we can go and count the length of A1 and then the length of B2, right? So
Okay.
whichever is bigger, and then we
Right.
take a difference.
Mm-hmm.
So whichever is bigger, in this case, B1 is bigger, right?
Right.
So we advance B1 for the next pass actually. We
Right.
advance B1 by the difference.
Yep.
Then we are at B2, and then we again start A1 and B2 from
Right.
there, and then find the intersection.
Right. Right. So this was, yeah, this is, kind of an approach where we are using this 2 pointers approach, and we are using this idea that we are starting one pointer X steps ahead of the second one, and then we are just traversing the two lists linearly, right? But to me, I put it in the category of clever solution to seemingly simple problems. Like I can't come up with this idea if I haven't seen this technique. So, but it's good to learn, right? Like that's another point of all these algorithms, that we know certain algorithms and there are certain which we can learn by, new ones. So does everybody see what Santosh was saying? That the top list A has 5 nodes, right? And the second list B has 6 nodes. So you take the difference, which is 1, and you advance the longer list by that many nodes. So you start from B2 for list B. And then you just traverse linearly, one step at a time, both the list. And where they meet, that's when you know that's the node, right?
So
Uh,
there is one solution which Santosh mentioned, right? What would be the naive
yes.
approach? Will be that only, right? What Santosh was mentioning, or will it be anything?
Well, I didn't think of that as a naive approach. Actually, it didn't occur to me. I was thinking more as my first thought was, can I store the, let's say if I traverse one list, can I store its values in, for example, a hash set or hash map, like something like a structure array. And then I traverse second list. And if I find the same value in my map or set, then I know that's a common. But after I thought about that, then I noticed one caveat, that the same value can happen in this list. For example, I have A1, A2, and I have, let's say, I have another node here, for example, like before it gets to C1, let's say I have another value C1 duplicates, and then that C1 connects to this common node C1, right? So in general, what I'm trying to say is, I mean, my approach had loopholes, right? Let me just quickly, so if I had this value 1, 2, 4, 7, 8, and another list I had values like 4, 6, 3. I mean, I'm trying to say that if there are duplicate nodes and they may not meet here, right? What if this is my intersecting node? Or let me actually call it 3 here. So let's say in the diagram that the way the lists are intersecting, let's say they are intersecting at this point, and actually, sorry, I'm just coming up with this example here. Yeah, let's say my lists are intersecting at this second last 3, right? But if I follow my approach, I will detect a common node right at here, which is not the right answer, right? Like my list, does everybody see?
Yeah, but
But
in that case, yeah, you can store
yeah,
your
you need
pointer.
pointer. Yeah.
Yeah, yeah.
Exactly. So I can't, my the reason I'm explaining this is, definitely this is not the right approach, but coming to the naive thing, right? How I would think of the solution. So if I came across this and then I thought, oh, this won't work, then I know I have to store somewhere reference to the actual node, right? I can't go by values. So that's where I thought that maybe I can put, my next question was, can I add a is visited flag in my linked list structure? Like, is it mutable? And if I can do that, that's my second approach. That is how I was progressing in my thought process. But maybe some of you can directly get to this, idea of pointers. But I didn't get there right away.
So DP, not like actually, whenever you are putting the hash set, right? What value you are putting, you might be putting a primitive, right? Let's say integer or something.
Yes,
Rather
yes.
than that, if you put the list node or the
Yes,
object,
exactly.
right? So in this case, even though your values are same, but your objects will be different,
Yes,
right?
yes, exactly.
So
Put like the
then
node.
this issue won't happen, right?
Yep,
Yeah.
yep, exactly. But yeah, that's perfect. So like if I start with values won't work, but if I hash the node reference, then that would work. But yeah, this is how I was thinking about it. And then this runner technique was something I noticed after I started doing these questions. I mean, I was just trying to answer somebody's point about this runner technique is going to be the naive approach. To me, this wasn't naive, but maybe it's subjective. So.
So shouldn't like I agree with like putting the pointer nodes in there, but internally hash set is gonna use the equals method, right? If the nodes have a equals method on a value, then this may not work, right? I mean, how are we saying that hash set when we do a
No,
content?
so hash set, for example, rather than putting primitive, you would say something like this, right? Um,
Yeah. So, but what about the equals method? Like equals method on a list node, what is gonna return?
it's going to, okay, this is good. So you're talking about that equals and hash code override, all that.
Yeah, I
Yeah.
mean, I'm talking about list node dot equals or list node
No.
equals.
So, okay. So if you do dot equals, I think that's where it compares values. And if you do this equals, then it compares the references, I
And
think.
hash set, if it's null, then it compares the, I think if it is not null, it compares, it does the dot equals.
Oh, is it? Okay. Yeah, I mean, specific things I have to check.
Yeah, so if it has not been overridden, it will take equals from parent, from object, and object by default check compare with just reference.
Mm-hmm. Okay. So then that will work, right? Like if we store reference objects, then
We
yeah.
have to use dot equals, I think, if we store object, not the equals equals sign.
Okay. We are saying because we are storing objects, it will take care of comparing the references. Okay. Good learning.
So other way, like you can go to C3 and from there check which two nodes have different address. I mean, from till from backside and yeah, like that.
But how will you traverse from the backside?
So from while one linked list to reach to the end C3. Okay. Now you keep one more. Take the copy of this pointer. So start two pointers and start checking the address. If both the address are same, go to next. Whenever you
No,
find
but my question is that when you, let's say, do the first list and you get to C3, right?
yeah,
The
yeah,
second pointer is at B1, right?
yeah.
So you compare them, they are not same. Then you advance B, but what will you do with C3? You can't go back, right?
Back I can't. If we
I mean, one way is if you think of recursion, sort of, if you're popping from the stack, but then it becomes like an extra space.
yeah, one,
That's the whole challenge with this singly linked list, right? Direction aspect. But yeah, these are the kind of ideas we want to keep in mind, right? To brainstorm. Great. Um, this makes me think that I have to go back to my Java basics here on hash set. It kind of trumped me here. So yeah, so far we have talked about this iterative solutions where we use extra variables, to for the code implementation. We talked about this two pointers approach in linked lists. where we are not going with the array-based solutions where we have sort of sorted array and stuff, but we are thinking about moving at different speeds. And the third, well, this is kind of gets into miscellaneous zone now. I have two more problems and then we can jump to the practice session. So this is an interesting problem about merging two linked lists. So somebody wants to go through the ideas you have about how to do it.
Yeah, here like again you keep a dummy node and just compare whichever values is lesser that you append to the dummy node and then increment the pointer in that particular list and again
Right,
compare.
right. Typical like a merge merge algorithm, right? Like
Yeah.
comparing these, you start with a dummy node. Now my intuition here of dummy node was I'm creating a new list right here, and I don't know what my head pointer should be, right? It can come from the first list or the second list. I don't know yet. So I, as a simple solution, I start with the dummy node, right? And then I link it to, and then I follow the same, the standard algorithm, right? I compared the current nodes of both the lists, whichever is smaller, I add that to my final list. And like in this case, 1 and 1, I just pick randomly like the first list, I append that, and then I move the pointer of that list to the next node. And again, I compare the current nodes, whichever is smaller, I keep adding that to my list, right? Um, so the space complexity is order of m plus n, where m and n are list of the length of the list, and time complexity is also the same. Can we do better on this?
Oh, that is better.
Yeah. So here we see the time complexity is total number of nodes, right? And space complexity is also total number of nodes.
No,
Now,
the time complexity will be whichever list is having larger, what you say.
right, but still it will be total number of nodes, right? If you have larger, like 100 elements in one and you have 2 elements in another one, you still
Yeah.
have to traverse both the list to
No,
form.
no. Once you cover the shorter list, you directly attach the 98 elements directly
Oh,
to
right,
your.
right. Yeah, but that would be sort of not the worst case, right?
Yeah.
That would be like a best case sort of, that you're getting
Yeah.
less time.
Exactly.
So worst case would be like you have to, let's say, traverse both one by one. So,
Yeah.
so we know that we have to, time wise, like the solution you just talked about, right? If one list is arbitrarily wrong than the other, then the time can be less because you just attach the, longer one at some point. But that depends on the given input, right? How your input is. Now, let's say if even in worst case scenario, let's say both lists are same size, um, uh, we can't really improve the time complexity, right? We have to do all these comparisons. Is there a way to improve space complexity here?
Then in the same node, if you can do something, right? That is what you are saying.
Right, right. Like rather than creating a third list, right? That's where we are consuming extra space. So the question is, is this something we can do in the existing given input list that we don't need a third one?
Then binary search, you take each node of the first list and do a binary search on the second list and see where it fits.
Um,
That will
Binary
be
search
Not like
won't
sorted.
work,
Well,
right?
it's sorted. Sorry.
list is already sorted, right? So
Yeah,
one
yeah.
list but that will be complex, I think, more.
That will be complex, right? Like
That's
you
n
will,
log n,
yeah, you will
right?
actually lead to
Okay.
higher time complexity, right? You will
Yes.
with the space, right?
So you can do a recursive way.
Mhm.
But what you're trying to achieve here, you want to reduce on the space, right?
Right. That's, yeah.
So we can actually just play with the pointers of both of these list inputs, list whatever we were getting, right?
Mm-hmm.
So if we do a recursive way, I think we have solved this problem sometime back when Naga was doing the session,
Okay.
right? So it seems like if we do it recursive, and if you compare the values of L1 and L2, so if
Yeah.
L1 is lesser than your L2, then you can actually say L1's next will be pointing to the merging of, you'll again advance your L1 because you know that that is the least one and you want that one. So therefore your L1 dash next will be pointing to your recursive function, and in that recursive function you will be just advancing the L1, not the L2, right?
That is the, without even thinking about recursion, right? That is the, in general, the logic we do follow, right? When we take one list node, then we advance that list node by.
Okay, okay. So yeah, so you're already doing that, right? Yeah.
Yeah, so it's not, so the idea, maybe I can just give a hint and see how far we go. So the idea they're using is that instead of the whole, the main way we can optimize space is if we can just play with these two lists and not create a third one. So think about if you create a dummy node, right, first, which we were anyways doing, and in this case, you compare one and you take, let's say, first one, right? And you set the pointer of dummy node to this. Can everybody see? Okay, here. You can see the clicker right here.
Yeah, yeah.
Okay. So you have a, let's say, a dummy node here, and then you point that dummy node to this one. And then you advance, like you said, right? You advance to this pointer. At this point, you compare 2 and 1, and you know that the next node is 1 here. So you change the, break this link here, right? 1 to 2, and you set the link of this one to this one, right? And you keep track of the next. Now you're comparing 2 and 3. The smaller is 2. So you set the pointer of your last node, right, that you have a handle on, which is 1 to 2, right? And then you compare 3 to 4. The smaller is 3. So you attach 2 to 3 and so on. So does everybody see the idea here they are trying to play with? So this is similar to like in reversal, right? We break the links, right? We break the list. We kind of rearrange the pointers, and we have to in this problem, the main point is you have to keep track of the node, of the last node that you need to attach to the rest of the, whatever the new list is coming up, right? You just need a handle of that. And you also need a handle of the next two nodes to look at. These are the three main variables here. I start with the dummy node. I have two pointers which are pointing to the current node of the two list. Those are the two pointers. And when I say dummy node, you can think of it as a third pointer, which is representing the node to which I want to attach my next node. Does that make sense?
Yeah.
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 Manipulation of pointers will be lot here. Like, I mean,
I couldn't catch.
no, I'm saying manipulation of pointers will be lot.
Yeah.
Like,
Yeah.
because
But it was an interesting idea. I mean, this canonical way is what comes to mind first, using extra list. But this is also interesting how to play with, manipulating pointers.
Yeah, but in that case, if they say that we can modify the input list, then we won't be able to do it, right? Yeah.
Yeah, of course. That definitely. Yes. That's another question we can ask the interviewer, right? Are the lists immutable? Can be.
Correct. Yeah.
So usually the in-place algorithms, I mean, a lot of them, they require, it's like a trade-off. Either you change the existing data or if you want to save it, then create new one.
Right. So because the question says it's merged to sorted list, it means that you have to merge them. So you really don't need them. Yes, right?
Yeah, I mean, that is,
Yeah.
that's a tricky thing.
Yep, yeah.
But yeah, that was an interesting algorithm here. The other one is a variation of it, which comes under the hard problem. It's merge k sorted list. And there are different approaches to it. So we can quickly talk about some, but won't have. How about this problem, right? Now you don't have just two lists, you have k lists available to you. Um,
Yeah, here again, you can use previous. I mean,
uh-huh.
like just go with the merge sort, right? And with the midpoint of the list
Right.
and zero to mid and mid plus one to end. And just similar and the previous approach, what we did for merging, just make a function and pass it.
Right, right. Like a very simple without getting into complexities, right? You just, if they're k lists, you start with k pointers, right? Each pointing to the start of the list. Compare values, keep appending advanced pointers like that.
That you can do in array, I think. I mean, we have array problem also, like merge k sorted arrays.
Uh-huh.
The one merge k sorted arrays where we keep pointer on head of each of the arrays, and you either you put all those elements into heap and take the minimum one, and from whichever array you got, you take the pointer in that.
Right, right. Yeah, even that's true. So this can be similar. I mean, in general, given is like an array type only. So
Yeah.
yeah. So there are like different variations, not variations, different ways of addressing this. A very simple thing is you create a new array, dump all the values, just as is, right? 145, 134, 2 comma 6 in that array, sort it,
Yeah, that's it.
right? And that's it. So that requires extra space. And it requires sorting, right? And log n. The other way is the merge algorithm we were talking about. Use k pointers and just iterate through each list and pick the minimum. That would also require, like, if you have k list, then you are running you have to try to find the minimum amongst those k values in every iteration. The other idea was that leverage the algorithm, this in-place algorithm that we talked about here, which was with two lists, right? So if you do it with first two lists and you get a new list, right? You lose these two lists, but you get a new one with a merge one. And then you take the result of that and you merge with the third one, right? So you like start with two and then keep adding one more list, and you can do it in place if you are allowed to change the lists. So it's kind of talking about, let me share, that will make it
It,
more clear.
it will also be n log n only, right? Because merge sort we are using only space you are just
Yeah, space will be optimized, right?
But why this will be n log n?
because you are following merge sort only, right? You are taking the midpoint of the list
No, no,
and
no,
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 she's
no,
not
no.
taking the words. She's
I'm
taking
not
the
merged.
previous
Yeah,
previous
okay,
solution.
taking three pointers.
Yeah. So it should be O of k into n
K
whatever
to
it is.
N, yeah. So if you see this solution here, so what, this is something I got the hint from the solution by lead code. So we are trying to do merge of two lists to begin with. And then that merge, we are doing this in place, right? Where we are starting, this is a dummy node. And then we are starting with, just manipulating the pointers and getting a new list, right? And from there, we just, add one new list at a time from my given k list, and I just keep merging there. And yeah, so this is more the main idea I wanted to, and there is another solution which I didn't want to take up today because it requires priority queue, which most of you here would be very comfortable with, but just to take it in a methodical manner, I thought we'll hold on to that. But this is a good question, I think, from the interview perspective to really see the thought process of the candidate, right? There can be so many different solutions with each with its own trade-offs. So, yeah. Any questions on this?
So on this line 23, yeah.
Yeah, yeah.
So why are you starting with I equals 2?
Because I have already merged the first.
Oh, okay. Sorry. Yeah. Yeah.
Yeah.
First you do with that header. Okay. No
Yeah.
problem. Fine. Okay.
So that's that. I think that was pretty much in terms of the problems I solved and kind of the summary I had. Any other? I mean, of course, there are a lot of different problems to try, and practice is the key. But as a concise, like high level perspective of different types of problems you can get in linked lists. This was it. Any questions on any of this before we move on to our practice session?
Do you have proof for that? You told you'll discuss for
Oh,
the card.
yeah. So since it's like practice, we are past time. So let me post that proof online. The idea was that I can give you an idea about how they were thinking about this. That the the way is that so the fast pointer. So what are the different scenarios you can have? You can have a fast pointer. Let's say is um, is either like I can take an example. So there were two cases, right? Fast pointer can be at some point even behind the slow pointer by one step, or it can be behind the slow pointer by two steps. And I would probably possibly have to take an example to illustrate it. But let me just post that because otherwise I would need time to explain it.
Yeah, yeah, we can discuss no problem.
Yeah. So let's move on to the practice session. Let me see how many of us we have here. We have 23. Again, I don't know. Just want to reinforce this is not, you shouldn't feel pressured about this session, a practice session, because um, each of us will be in a room of two people where we'll be trying a problem, and I would encourage one of you becomes an interviewee and one becomes interviewer, and you can decide amongst yourself who wants to do that. And this is not going to be recorded, so it's just more like a real timed practice you will get on a question. So we'll try this for um, and another thing before we move on is try to think of it as like how would you approach in an interview, right? Starting from naive approach, trade-offs, thinking of a solution. And you may not finish the problem, but that's fine. So let's take about I don't know, you want to take 20 minutes I mean, in an interview typically you would get about 25-30 minutes, but uh, what how should we go about it? Like, we have time till 10:30. I want to keep about 5-10 minutes for discussion. So let's go with, you think 20 minutes is good, or
Yeah, 20-25 should be fine. But can
okay?
you actually display the question before we break in the
Yes,
room? Because
yes.
last time we had a problem, right?
Right. Yeah, I'll
Okay.
display the question here, and then I'll launch everyone in a breakout room. If I see anybody is in a room like by themselves, I'll try to make put you in a room with somebody else. But in general, if you happen to be by yourself, just use the time to solve the question and think about it in 20 minutes. So let me bring up the question here. It is um, 143. Everybody sees the question in the chat, right?
So you're putting the chat. Okay, what it says, given a single linked list.
So yeah, let me just also put you all in the room so that
Okay.
we
Just
have what, 19 people.
convert to the list. Okay. So
Okay, so how was the problem, like level of easy, medium, hard? What do you guys think?
Yeah, the problem was fine. I mean, we were able to get to the logic, but
Okay.
we couldn't complete the code.
Yeah.
Yeah, it
Just,
was
thinking
at
about
the
the,
answer level, but yeah.
yeah, coding level may need a little, some more
Yeah.
time, but at least you were able to get to the approach and talk through it, right?
Yeah, so the main challenge I think in the coding would be when we are realigning both the list, right? Because the first two parts are simple. First, we have to divide the list in two,
Mhm.
and you reverse the second one, correct? But third, when we are interleaving, intermixing both those two lists, that's the more challenging part, right?
Right.
Okay.
Even actually the one that you talked about, you all can see my screen, right?
Yes.
Yeah, so I think Santosh, you're talking about the middle of the list and stuff. I think that is like, having gone through the problems today, I could think of it, but it wasn't the first thought that came to my mind. But yeah, you're right. If we follow that idea, that then those pieces are okay, but just manipulating and shuffling the pointers is tricky. Um,
Right. Yeah.
Yeah.
so
Yeah, that's what we got stuck to. We actually use a hash map. So what we did was me and Suzit work on it. So we first try to put the index and the node on our hash map. So we have, so we know, index for every little nodes, and
okay.
then we try to loop to the same hash map, made a for loop because now we know what our ending is, and
Uh-huh.
then we try to connect playing with the pointers. And the challenge we were having trouble is, so on our first input where it says 1 2 3 4, we could connect 1 and 4 and 2 and 3, but we're working on pointing how to connect point 4 to 2. Yeah,
Oh, okay. A kind of how to insert it between one and two.
exactly, yeah. But
Okay.
it was fun, yeah.
But basically, you use the idea of indexing
Hmm.
to figure out the first and last. And then you find, let's say, using indexing, you found this was the last node, right? And you
Right,
put its value and you try to, um,
connect.
okay, connect that. Okay.
Mhm.
Yep.
So what is the in-place approach DP was
Yeah.
mentioning?
So this was
Can you
like,
explain a little bit?
yeah, sure. So what we just talked about, the hash map, or that indexing idea, that we know that would require extra space. The other idea in place one is, you get to the, so let's talk about the intuition, right? So you want to connect, you want to put pick the last node, insert it in the middle, like between the first two, and so on. So we, given that it's a singly linked list, like question is, how do we kind of get a handle of the last node and then one node before it, all of that. So the in place algorithm is, you get to the middle of the list, right? For example, in this case, 1 2 3 4, you detect, let's say you stop at 2, and your second list is 3 and 4, and you reverse it, right? So you make it 4 comma 3. Like if I see this example here, like the way I'm writing code, so here this would give me, my first list will be 1 comma 2, and the second list will be 3 comma 4, and in the next step I reverse my second list, which becomes 4 comma 3, and I have pointer 1 at the beginning of the first list and pointer 2 at the beginning of the second list, right? And then
Yeah, I see. Yeah.
just traverse them, and I just keep, um, shuffling the pointers. So that was like the in place, and I think Santosh, you were talking about this one. So that was one. Another, the way I started approaching was like, I had a hint of this, right, going over the problems we had today, but I also thought about what can be another way. And in general, this is one pattern I have in mind, that in a single linked list, if I were to traverse the list backwards, recursion is another way, right? Of course, it uses extra space with stack, but if let's say if that was allowed, or Another thing was when I started solving this problem, I thought of this recursion, and then in my mind, I'm like, oh, recursion is a little tedious to write. But this is one thing you want to be careful in an interview, right? If we suggest a solution and if we are not proficient in it, then we can just, we are kind of uh, making it hard for ourselves. Like we are letting the interviewer know that, oh, recursion is not something that I'm comfortable with, right? That shouldn't be the reason, I think. So I mean, for my own practice, I started writing the recursive code here. So um, I have to, I mean, it's not complete, but this is how I was thinking that. Anyway, this is not the most efficient one, so I don't know if you want to discuss it, but this is the in place one. Uh, yeah. And then I took a test case that if a list has if the list is empty or one or two nodes, then I don't need to do anything, right? It's already, actually, if I have two nodes, I probably want to.
No, two node is fine, right? You can still have written it.
Yeah, two nodes.
No, if I have 1 to 2, don't I want to bring two in the big? No, I don't.
No, that's right. I
One
No,
think.
and
you
two
don't
is
have to that. Yeah.
Yeah,
same
yeah,
it is. Yeah.
yeah. So yeah, that was
Your this recursion is a very interesting one, right?
yeah
So if we are able to do it, it will be a very less
simple,
code.
like
Yeah.
yeah, very simple.
Hmm.
So I was trying to do like using recursion. I stop at, let's say, 3, right? And I stop at 3 because I want to get a handle of 4, which is possible, right? 3 dot next. But I also want to set the pointer of 3 to null after I move this 4. So I need to have a handle of 3, and which is where I check this condition, right? Um, and then this is how I was manipulating it. So I keep doing this recursion, and when I hit this condition, in this case I stop at 3, and in this case I'll stop at 4. So, and then I catch hold of 4, I insert it after 1, and I have to attach it to 2, right? And I have to change the point. Oh, well, I'm talking about 5, sorry. So I have to move 5 after 1 and attach 5 to 2, and then set the pointer of 4 to null. So this is what I was trying to do here. But I have to test it.
Mhm.
Yeah. So any other thoughts or?
So the other was like a very simple one would be
Mhm.
just run through the whole list and
Yeah.
copy it in an array, right?
Okay.
An array of list node actually, and then you have a two pointer approach,
Okay.
and then actually you keep on taking the first one
Yeah.
from the left and the right and with an additional space and forming a new list and returning
Right.
it.
Yep. Yep.
That was one, yeah.
Yeah, but I think it's very important to start with these basic ones and then improve. So.
But the array one is the basic one, right?
Yep. Yep. Everyone is the
Okay.
basic one. Yeah.
And I think these medium difficulty level questions, right? Normally, the intention used to be, very less and time efficient, right? So that's at least what I think of, from interviewer's mind, right? Because
Uh,
that gives us chances of error is high as a
yeah. Yeah.
candidate.
Like right. Right. And
Yeah,
actually, if
very
you see the
important.
acceptance rate, that's what. Yeah, it's saying like some questions.
Yeah, if you see it is not even 30%, right?
Yep. Yep.
800K submission to 300 is
Right.
very low.
Right. Right.
And one more thing, when we are actually dividing the list into two,
Yeah.
and if our list is odd size,
Yeah.
so I think we should take the list which we are going to reverse. That should be a smaller one.
Yeah, I mean, if I do this one, right, and
Mhm.
if I follow the fast and slow pointer, it will stop at like my first list will be 1, 2, 3, and next will be 4, 5.
Mhm.
Yeah,
No, here at max the difference will be of only one node, right? Because mid we are finding.
different
So
one node as in.
I mean, if you break the list into two parts,
Right.
then the length difference will be only one, because at mid only you are trying to break, right?
Yeah. Right.
So
Yeah, but it's always good to have the release which you are going to reverse. That should be a shorter one. So when we are actually manipulating the pointer at the end, and mixing that two least, so we can always just watch on the last least.
Yeah.
So that is slightly, it's a very what is a corner
Subtle.
case, yeah,
Yeah.
but that helps a lot, yeah.
I think Sasank wrote a code that, I mean, so one way is that if you are certain that it is always the first list is have an extra element, if it is there, then you basically save extra one if condition. That is, you can always add a if condition saying that if whatever is remaining have something, just
Oh,
append
right.
that. Either one of these lists,
Could you come again, Bhavesh? I
So,
didn't
so,
follow
so,
that. Yeah.
so see, you are basically you will have a function that takes L1 and L2 and merge it, right?
Right.
Right, and let's say that L1 you start at the beginning, and then L2's one element you pick and put in the middle of this L1, right?
Yeah.
So basically, we have two conditions. One of this list have one extra element.
Yeah.
If you are not certain at the end, whichever list has extra element, you just append to this new list. If you are certain, as you said that whatever you are reversing, you keep one element less there, then you always look for extra element in the first list only. Otherwise, you look for the both lists, saying that, oh, if it has any extra element, just append it.
Yeah, it's more about how you splitting it.
Isn't the same as the merging to linked list, right? One could be shorter, one could be longer. It could be, right? And we just need to make sure whichever is ending, just append the remaining list to the merged one, right?
Yeah. So that is what I'm saying. So I mean, if you even I was just commenting to the comment where we say that Santosh's comment where we say that we can have always the link that is not reversing one longer, but I am saying that in general it is okay whichever way we go.
Right, yeah.
Yeah, that's correct. Yep.
Yeah.
Okay.
Yeah. Any other questions on this? There's one last quick thing I want to check with everyone here before we close. But if there is anything else on this, please feel free to speak up.
Yeah, I think we are good. Yeah.
Okay. So one thing was, as I'm preparing, I'm kind of going over these problems. I would like to have some feedback. Is this kind of making sense, or there is another approach? Like there are different ways of looking at these patterns, right? You can look at it algorithmically, right, where you're not constrained with one data structure, or we can continue with next time I can take up stacks and queues, problems on those. But is this something that you all are finding like useful, or or is it a little more very much like narrowed down or simpler problems?
I think this is good, right? The way we are going ahead.
Okay.
I agree to that. That's because the more we do is always good. So if we are
Right.
doing with the simple data structures and then go on for more complex ones, and then after we find some more time, then we can mix and match also, right?
Yeah, that's what I'm
Right.
yeah, that will be
Yeah, it's
and
good.
yes, sir.
I like how you put because each of these problems, they all have patterns, and I like how you put all these patterns in the plain words. I mean, I can't memorize the problem, but I can memorize the patterns. So the patterns, bringing out patterns is very helpful. So thank you.
okay. Great.
Yeah, I think
So one other thing, Dippy, what I can think of, right? If in the future, let's think about that merging case sorted linked list.
Yeah.
Whenever we are coming to the heap section, if we see, oh, this problem we solve in the linked list way, now we are solving in the heap way, right? So that, so the reinforcement of the pattern will be more concrete.
Sure. That's a great point. Yeah. Something like to reference, we have done it another way and link list. Yeah.
Yep.
Okay. yeah, like, any comments or feedback you have, let me know. This is the first time we are doing something of this sort, so I don't want it to be totally going by my interpretation and thought process. So bye. If you're finding it useful, great. So I think that is
I
pretty
think Bhavesh had something to say, right? Yeah.
sure.
No, I had the same comment that I think Sujit already said. Basically, if we have a doubt saying that same, so the original question DP asked is we are going data structure one by one, right? And maybe 2 or 3 data structures share the same pattern. Then
Right.
we can discuss that, saying that we already discussed this and this is the same pattern. So we can link that way rather than going by pattern and then apply
Yeah.
on different data structures. So this
Yeah,
is
because
fine.
if we just go by pattern, it requires somebody to be comfortable with all the data structures.
Yeah.
Step by step. Yeah.
That's correct.
Okay, great. I think then we'll meet again. I mean, next week we'll be done with programming, and then we'll meet after that for stacks and queues.
Yeah, I'm just stopping recording.
2021, done with 2020. So.
Oh yeah.